Let us discuss determinant, class 12th, 4th chapter. Determinant of a matrix is a single scalar real or complex value associated with every square matrix A. It is denoted by det of A or mod-like structure A. But determinant and modulus are not same. Okay. Determinant of a matrix is different from a modulus notation. Now A, suppose there is a matrix with element A, then mod of A will be A. If you have a square matrix 2 into 2 order, then A, B and C, D are the elements, then determinant of A will be cross multiply AD minus BC. Okay, if it is an order of 3 into 3 matrix, then how you will find the determinant? To find the rule, there is a rule that you just consider first element A11 and just cross this first row and first column, then you will get A22, A33, same way cross multiply and minus A32, A23. So A11 and determinant of this. Okay, then minus A12, second element of the first row, minus A12 we will take, and you just cross this one, you will get A21 and A31 and A23 and A33. So that determinant we will write here. After that A13 plus A13. So first row, third column cross. So you will get A21, A31, A22, A32. That determinant you have to take. Now sign along row will be alternatively positive and negative, means for the first element A11 positive sign, for the second element A12 minus sign, for the third element A13 plus sign. Again, if you have 4 into 4 matrix, then A14 will have a minus sign, and then we will find the corresponding determinant of the lower order. Okay, this is the rule. We will discuss it in the problem. It will be much more clearer. Example, this is your determinant, matrix A with element 3, determinant of A will be 3. Matrix A 2, 5 and 6 and 5. So your element will be, this is minus 8, So 2 into minus 8 minus 6 into 5. So your answer is like this, minus 46. Determinant of A, so 4, then this one, minus 1, 1, 1, 0 will come here. Again minus 1, first element, second row or second column, minus 1. So minus 1, minus sign will come here. Then cover it, you will see 0, 2 and 1, 0 will come here. Determinant, you have to find that. Plus 2. When you will cross this one, you will get 0, minus 1, 2, 1. That determinant you have to find. And then simply solve the given expression. Okay. Now, second important concept in determinant is minors of any matrix. Suppose this is 3 into 3 matrix, you have to find the minors. Minors Mij of the element Aij is the determinant obtained by deleting the ith row and jth column. Means minors is nothing but, suppose you have to find the minor of A11. So you will just cross this first column and first row. Means A11 is lying in first column and first row. So you will cross out. Whatever is left, that is called the minor. Okay. So minor of A11 is this one, A22, A23, A32 and A33. That determinant will be the minor of A11. Similarly, suppose A22 you have to find. So you will cross this one, second column and second row. You will be left with A11, A31 and A13 and A33. Like that you have to find the minors. Now second important concept is cofactor. Cofactor is nothing but cofactor of the element Aij is Cij denoted by, it is the minus 1 power I plus j into Mij. Means together with minor you have to put one extra number like this, minus 1 to the power I plus j. That will be your cofactor. So suppose C11 will be minus 1 power 1 plus 1 and Mij means minor of A11. So A11 minor is this one, A22, A23, A32, A33. In that way you have to find the cofactors. So cofactor is nothing but, it is preceded by, minus will be preceded by this expression, minus 1 to the power I plus j. Okay. only that thing you have to keep in mind. Okay, now come to the adjoint of a matrix. It is the transpose of the matrix of cofactors of A. Means you have to find the cofactors of all the elements of A, then transpose it. Means row will be interchanged to columns. Then that matrix is called the adjoint of a matrix. We will see in the examples later on. Now come to this point, inverse of a matrix. Inverse of a matrix means a square matrix is invertible if and only if it is non-singular, means determinant should not be equal to 0. Non-zero determinant should be there, okay? Because if the determinant becomes 0, not defined type of case comes. So A inverse can be written as 1 upon determinant of A into adjoint of A. Adjoint of A is the transpose of the matrix of cofactors of A. Okay. So now area of triangle in the form of determinant. So half of, suppose these are the coordinates of the ABC points, x1, y1, x2, y2, x3, y3. Then half of x1, y1, 1, x2, y2, 1, x3, y3, 1. Whatever determinant will give you, that will give you the area. Now properties of determinant is also very important for the solving the sums. Few properties. The value of determinant of a matrix and determinant of a transpose of a matrix are same. Means the value of determinant of a matrix and determinant of a transpose of a matrix are same. Means A determinant and transpose of A determinant will be same. Now if any two rows or two columns are interchanged, the sign of determinant changes. Means if you are changing row 1 to row 2, R1 is changing to R2, then sign will be changed, okay, of the determinant. You will see by examples. Just you go through this. If any two rows or columns are same or identical, the determinant will be 0. Okay, if there are two common rows or three common rows or three columns are equal, two columns are equal, then determinant value will be 0. So this is very useful in solving the various problems. Now come to this. If each element of a row or column is multiplied by a scalar or a constant k, then determinant is multiplied by k. Okay, if each element of a particular row, not necessarily that all the rows, if one row or column is multiplied by a constant k, then the determinant will also be multiplied by k. Okay, adding or subtracting a multiple of one row or one column to another does not change the determinant value. Means if you are just adding or subtracting the columns or rows in between them, once one row is added to the another row, then the determinant value will not be changes. Same for the columns.